Hello and welcome to Math with Mrs. Becker. Today we are looking at Algebra 2, Chapter 1, Section 8. We will be studying transformation. Now, in case you're asking yourself, what is a transformation? A transformation is any change in the position, the size, or the shape of a figure. The first transformation we are going to look at is called a translation, also known as a slide. And what happens is you take, whether it's a point or a line or a figure, and you can slide that figure to the left, right, up, or down on the coordinate plane. So here is a point, okay? What you need to realize is that on a coordinate plane, the x-axis goes side to side. So if you are going to move to the right or the left, we have to change the x. The y-axis, remember y is the second value of the ordered pair, the y-axis runs up and down. So if you want to change your y value, or if you change your y value, what it's going to do is take that point and move it upwards if you add or downwards if you subtract. So here is the point. The point is -3, 4. If we want to go to the right, 5. Right is horizontal. So what I need to do is take the x value. The right is the positive direction, so I need to add 5, and I would go ahead and keep the y the same. So if I look, I had a -3 plus 5. Again, I'm keeping the y the same. -3 plus 5 is 2, 2, 4. So if I go to the right, 1, 2, go up 1, 2, 3, 4. If we look, this is 1, 2, 3, 4, 5 units to the right from our original. To move to the right, you add to our x value from the ordered pair, okay? If I want to go 2 units left, left is the x-coordinate because the x-axis runs left and right. So what I'd have to do is take the x value. If I go to the left, that's the negative direction, so I'd have to -2 to go left 2. Then, if I want to go up or down, and here they want us to go 2 units down, I need to change the y. To go down, that's the negative direction, so I would -2. So in order to do this, my original x is -3, I'll have to -2. My y is 4, I'd have to -2. -3 minus 2 more is -5. 4 minus 2 is 2. So if I go ahead and I go to the left 1, 2, 3, 4, 5, and then up 1, 2, this is left 2, down 2. So the big thing is realizing which coordinate you need to change, okay? Here's another example just to make sure we've got it. We are starting with the point -1, 3. If I want to go 4 units to the right, left and right, that means I'm changing the x-coordinate. Going to the right, that's the positive direction, so I would add. I'm not changing up or down, so I keep the y the same. My x was a -1. -1 plus 4 is 3, so it's 3, 3. So I go to the right, 1, 2, 3, up, 1, 2, 3. This point is 1, 2, 3, 4 units to the right of our original point, -1, 3. Let's look at another one. If I want to go 1 unit to the left, going left or right changes the x. If I want to go to the left, I -1. Then it's 2 units down. If I want to go up or down, I change the y. To move it 2 units down, I -2. My original order pair was -1, so -1 minus 1 more would give me a -2. My original y was a 3. 3 minus 2 is 1. So I go to the left 2, up 1. This point is 1 left and down 2 from the original. Kind of fun. I kind of like doing these transformations. Now here's another one. Again, we're just looking at translations. It's kind of what I talked about, but I do think it's helpful to have a slide that just kind of reviews everything. So notice when you go left or right, you change the x-coordinate. Okay, if you want to go to the right, you add. If you want to go to the left, you subtract. If you want to go up or down, you change the y-coordinate. If you want to go up, you have to add to the y. If you want to go down, you have to subtract. Okay, so that's just a little reminder of what we did. Another type of transformation is called a reflection. A reflection is kind of like a mirror image. And we will do reflections for or across 2 different lines. We will reflect across the y-axis. And what that means is it's like you're putting a mirror image here. In order to reflect across the y-axis, in your ordered pair, you keep the y the same. If you're reflecting over the y, you keep y the same. You have to change all of your x's to the opposite sign. So what that means is all negatives become positives, all positives become negatives. If I want to reflect across the x-axis, that means it's like a mirror image here. To reflect across the x-axis, you keep the x the same. What you need to do is change all of the signs of the y-coordinates. Anything positive becomes negative, anything negative becomes positive. So again, to reflect across y, you keep y the same, change the x. To reflect across x, you keep x the same, change the y's. Let's do some flipping. It says you can transform a function, okay, so more than just 1 point. We started off with 1 point. We can transform a function by transforming its ordered pairs. So what you'll do is take the ordered pairs that create the figure, go ahead and change them accordingly based off of the transformations that are occurring, and then you go ahead and plot the same points. So if I look here, the way that they got these ordered pairs, this is -5, -3. This is -2, 0. So those 2 points helped us to get that line right there. Then 0, 2 got us to here, 2, 0, and 5, -3. If they want us to translate it up 2, remember if it's up, what that means is you keep the x the same, up and down is y. So what you do is you take all of the y's and you add 2. So the x would stay the same. The y was -3 plus 2 is now -1. The x stays the same. The y was 0. 0 plus 2, now it's a 2. The x stays the same. The y was a -2. When I add 2, it becomes 0. The x stays the same. The y was 0. 0 plus 2 is 2. The x is the same. Take the -3 plus 2, it's a -1. Now I plot these points and I should have the same figure. It just should be slid up 2 units. So I go to the left 5, down 1. I go to the left 2, up 2. 0, 0. So there's a line, there's a line. So far it's looking pretty good. Go to the right 2, up 2. Go to the right 5, down 1. There is the same shape, the same size. The whole figure just slid up 2. We did that by taking our y coordinate and adding 2. Let's do it again. Okay, so I have the same points. Just to kind of save us time, I wanted to make sure that you knew how I got the ordered pairs. They're the key ordered pairs that get us that shape. Okay, so there they are. If I want to reflect over the x-axis, that means you keep the x the same. I have to change all of the y's. When you change a sign on a variable, that's the same thing as like multiplying it by a -1. So here, my x stays the same. The opposite of a -3 is a +3. The x stays the same. -1 times 0, that remains a 0. There's no such thing as a -0, so 0 will remain 0. The x stays the same. -2, the opposite of that is a +2. 2 stays the same. There's no such thing as a -0. 5 stays the same. Negative times a negative, this will be a +3. So if I go to the left, 1, 2, 3, 4, 5, up, 1, 2, 3, there's a point. Left 2 stays at 0. 0, up 2. Go to the right 2, stay at 0. 5, 1, 2, 3. So when I connect these, it is the same shape, the same size, but it is a reflection as if there were a mirror at the x-axis. Super cool stuff. Okay, let's go ahead and look at this check mark. Again, to save us time, I found the ordered pairs for us. If I go to the left 2 and up 4, there's a point. Then -1, 0. So I figured that would be enough to get us that line. 0, 2, and then just to show that it remained constant, meaning it stayed horizontal, I picked another point on that line. If I want to go 3 units to the right, if you are going to the right, you have to add to the x value. So I take each x value and add 3. -2 plus 3 is 1. You keep the y the same. -1 plus 3 is 2. Keep the y the same. 0 plus 3 is 3. Keep the y the same. 2 plus 3 is 5. Keep the y the same. Graph those points. So I go to the right 1, up 1, 2, 3, 4. Go to the right 2, stay at 0. So there's my line. Go to the right 1, 2, 3, up 1, 2. So there's a little check mark part. Go to the right 1, 2, 3, 4, 5, up 2. This just shows that it remains as a horizontal line. Hope you guys are having fun. This is kind of like art class mathematical style. Okay, let's keep going. Imagine that if you took 2 points on the graph of a function on the opposite sides of the y-axis, so up and down, and you stretched it, what would happen is it would make the graph taller. But in order to make the graph taller, it's going to make it more narrow. Okay, what happens if you took those points on the y-axis, top and bottom, and you compressed them, meaning you like pushed them downwards? What would happen is the graph would be shorter. In order for the graph to be shorter, it'd become more wide. When you are doing this, you are doing what's called stretches and compressions. When you do stretches and compressions, what happens is your graph, it actually distorts its shape. It will no longer be the exact same shape and the exact same size. You are stretching it. So it might get taller and more narrow. It might get wider and shorter. Okay, the main thing here is that if it is a stretch, what that means is that you are multiplying by what's called a scale factor. You're multiplying by a scale factor that is greater than 1. So if the number you're multiplying by is bigger than 1, it's called a stretch. If you multiply to the x, it's called horizontal. If you multiply to the y, it's called vertical, because x is the horizontal variable in an ordered pair. The y is the vertical, because in a coordinate plane, the y is the vertical line. It goes up and down. The x is the horizontal line. A compression means that the number that you are multiplying by is less than 1. So here, notice that they're multiplying by 1/2. 1/2 is less than 1. So that is called a compression. It's being multiplied to the x in this case, so it's a horizontal compression. If it's multiplied to the y, it's vertical. So again, if the number is bigger than 1, it's a stretch. If the number is less than 1, it's a compression. If you're multiplying to the x, it's horizontal. If you're multiplying to the y, it's vertical. Let's do this. Okay, so here I have -1 up 3 and 0. So that's that line. Then it kind of did a funky little curve thing, like a little part of a parabola to 2, 2, and it remained at 4, 2. Okay, so we have our key points. If you want to do a horizontal stretch by a factor of 3, horizontal means you have to multiply the x's. It's a stretch because this number is 3. So what happens is you take all of the x's and you multiply them by 3. -1 times 3 is -3. You keep the y the same. 0 times 3 is 0. You keep the y the same. 2 times 3 is 6. You keep the y the same. 4 times 3 is 12. You keep the y the same. So if I graph this, go to the left, 1, 2, 3, up, 1, 2, 3, there's a point. 0, 0. So here's my line. And what happened is horizontal, they took 2 points on this thing and they stretched it. So they made it wider. Now if I go 6, 2, this curve right here, look how distorted that is. It was like a nice little curve, but they took it and they stretched it out. Now 12, 2, it's way off here, but it just is important to show that you know it continues in that direction. So that's what a horizontal stretch is. It's like you take these two ends and you stretch it side to side. So it does get a little bit distorted. So please don't be alarmed that the shape is not identical to what it was before. Okay, let's look at another one. Again, I use the same shape so you can understand where I got those ordered pairs. Let's take this and do a vertical stretch by a factor of 2. It's a stretch because 2 is bigger than 1. Vertical means I have to multiply that 2 by the y values. So x stays the same. 3 times 2 is 6. X stays the same. 0 times 2 is 0. X stays the same. 2 times 2 is 4. X stays the same. 2 times 2 is 4. So here are your new ordered pairs. I go to the left one up 1, 2, 3, 4, 5, 6. 0, 0. So here's my line. Okay, now 2, 4. Look at that. Whoop! And 4, 4. There's your new shape. Now, if it's a vertical stretch, what that means is you're taking the graph, the original, top and bottom, and you're stretching it. So that's why it becomes taller, and in the process, it has to become more narrow to make up for that height. All right, last problem. And then today there are some worksheets for you to work on, practicing taking things and flipping them and stretching them and compressing them and moving them up, down, left, and right. Super fun. Okay, the graph shows the cost of a painting, based on the number of cans of paint used. So if you use 0 cans of paint, well, obviously it costs you nothing. 1 can of paint, it costs you $50. 2 cans of paint, it costs you $100. 3 cans of paint, it costs you $150. So what I can see is that every can of paint is $50. Okay, now it says sketch a graph to represent the cost of a can of paint doubling and then identify what transformation happened. Well, here, the X is the number of cans, the cost is the Y. If the cost is doubling, what that means is I have to take the price, the cost, and multiply it by 2. So this is a vertical stretch. So 0, 0, but if I take the Y, 50, and I multiply it by 2, now it's up to 100. Here, the Y was 100, multiply it by 2, it's 200. Here, the Y was 150, that was the cost. If I double the cost, it's up to 300. So you can see that it just got steeper. This is a vertical stretch because you multiplied the cost by a number bigger than 1. You doubled it, meaning you took it times 2. That, my friends, is 1.8. I hope you enjoyed the lesson and have fun completing your worksheet. Talk to you later.